Hello, everyone. My name is Shengyi Gao, and I am a member of the Nanjing University Imaging Lab team. And today, I'm really delighted to share with you our solution that helped us win the championship in the VQA challenge competition. First, let me briefly introduce this competition. Given an image and a question about an object within it, we need to infer the answer and the corresponding bounding box. The official website provides 3 examples that show the target of this challenge in a clear and intuitive manner. So in traditional VQA tasks, we are given an image with a question and are required to provide a sentence as an answer. The similar visual grounding tasks provide a description of a target object in the image, and we need to predict its bounding box. This competition combines both of these problems. We not only need to answer the interrogative question, but also need to predict the bounding box of the object. This is the main challenge of this competition. And in fact, research on methods for visual grounding is now quite mature. Most of these methods follow a common architecture. First, an image backbone and a text backbone are used to extract features from the image and the text inputs, respectively. These features are flattened and concatenated together, and then passed through a head network to generate the final results. The paradigm is simple and effective, and has achieved great success in various visual grounding tasks. However, we have noticed that in this paradigm, the feature extraction process is independent, which means there is no information exchange between the text and image backbones during the early stages. This lack of interaction may make it harder to infer answers from the images. Therefore, our method does not follow this paradigm. We hope to encode the input of different multimodals into a unified representation and have a unified understanding of their features. UniPerceiver achieves this well. UniPerceiver is a VIT-based model. It can encode multimodal information into a unified representation space, and it has been pre-trained on a large number of multimodal tasks and has a powerful transfer ability. We convert the input image and the input question into embedded representations, and then combine them to calculate features. And finally, we extract the image features and reshape it into a feature pyramid, while the remaining text feature is directly discarded. We have also introduced VID adapter into our model. A VIT adapter is a pre-training free auxiliary network to the backbone, and it helps VIT extract more comprehensive spatial information. The backbone network is divided into multiple blocks that interact with VIT adapter through the injector and extractor modules. VIT adapter consists of 3 modules. The spatial prior module extracts spatial prior information from the image and generates a feature pyramid. And the injector module injects spatial information into the input. And the extractor module obtains multi-scale features from the output to update previous spatial information. Since the text information and the image information have been fully mixed and interacted in the backbone, we can simply cast this task as a single class object detection and use a general detection head. So we adopt Dino as the detector in our solution. Dino is a derivative model of the DETER series, which has a transformer architecture and currently performs best in object detection tasks. And this figure shows the overall architecture of our model. The backbone network is comprised of UniPerceiver and VIT adapter, which extract mixed features from both images and questions. The dino prediction head is responsible for regressing the target bounding box based on the extracted features. We have also incorporated an auxiliary loss into our model to further enhance its performance. In addition to the original loss in Dino, we introduced a segmentation loss. We extracted the feature maps of the last 3 scales from the feature pyramid and applied a FPN head to perform segmentation on it. Furthermore, we generated a binary mask based on the ground truth and calculated the dice loss between the segmentation result and the binary mask as the auxiliary loss. The total loss of our model can be expressed as follows, where we used a coefficient lambda to control the weight of the auxiliary loss. Furthermore, we also designed a test time augmentation specifically for inference. For each test image, we resize and flip the input image to obtain 6 images. Then we use our model to test each image and obtain 6 bounding boxes and scores. For each bounding box, we calculate its intersection over union with all other bounding boxes and add the mean value to its original score to obtain 6 corrected scores. And finally, we select the bounding box with the largest corrected score as the final result. And then let me introduce our experiments, starting by giving an overview of the datasets. In order to enhance our model's feature learning capabilities, we created an additional dataset for pre-training. The GQA dataset is a large and well-structured dataset, especially for VQA tasks. It contains a vast collection of images and associated problems along with their corresponding scene graphs, and it enables easy extraction of corresponding object bounding boxes. So we built a pre-training dataset from GQA with the same format as the official dataset, consisting of 50,000 images and 160,000 questions. We pre-trained our model on this dataset before fine-tuning it on the official dataset. Additionally, we configured 2 different sets of model parameters for performance and efficiency, and the model settings are listed in the table. And we finally submitted our large model, and its performance has been officially announced. We are thrilled to have won first place with a small margin. And on the right, we present sample results from our validation set. The predict bounding box are shown in red, and the ground truths are shown in green. We also conducted ablation studies to verify the effectiveness of various designs in our model. Here, we show our 9 experiments, each of which changed part of the settings. We start from a simple baseline that comprised of uniperceiver base and VIT-det. Firstly, we replaced VIT-det with VIT adapter and achieved a significant improvement. Then we replaced all window attentions in uniperceiver with global attentions, which also resulted in great progress. Next, we used a pre-trained T-file model to perform synonymous conversion on the input text to augment our data, which yielded some improvements. Furthermore, we added the auxiliary loss we designed for training, and it further improved the performance of our model. In the next experiment, we replaced the uniperceiver base with uniperceiver large. The larger model significantly boosted the performance. We also attempted pre-training on RefCoco and GQA datasets respectively, but obtained the opposite results. We speculate this is due to the gap between the 2 datasets and the official dataset. And we suggest that proper pre-training is necessary to improve the performance of our model. Finally, we added the test time augmentation we designed for inference, which further improved our model's performance to the best. So in summary, our team designed a new model by equipping UniPerceiver with VIT adapter as the backbone and using Dino as the prediction head to detect the target bounding box. We also introduced the auxiliary loss and test time augmentation modules to further improve our model's performance. To train our model effectively, we pre-trained it on a filtered and formatted subset of the GQA dataset before fine-tuning it on the official dataset. Through extensive experiments, we evaluated the impact of several factors on our solution and achieved significant improvements. As a result, our model won first place in this challenge. And overall, our work showcases the effectiveness of combining state-of-the-art techniques and highlights the importance of careful pre-processing and experimental evaluation. That concludes my report. Thank you for listening. And I would like to extend my congratulations to all the teams who have achieved great results in this challenge. Thanks.